Hello, this is Mr. Stein, and in this video we're going to look at example number 3 from section 7.2, solving a system of linear equations graphically. So by the time you're done this, you should be able to determine the point where two lines cross a given graph, graph linear functions in different forms by hand, graph linear functions using a graphing calculator. Let's go to example 3. Write a linear system to model this situation. Wayne received and sent 60 text messages on his cell phone in one weekend. He sent 10 more messages than he received. It's a typical guy thing. You send a lot of messages out to the ladies, and you get only a few in return. Graph the linear system, then solve the problem. How many text messages did Wayne send, and how many did he receive? All right, so let's start off by going through the process to create the system of linear equations. Number 1, define the variables. So let's do number 1, define our variables. So how many did he send and how many did he receive? So S is equal to the number of texts sent. And R is equal to the number of texts received. Step 2, restrict our variables. So can we send decimal texts, decimal amounts, or fractional amounts? No. Can we send negative amounts of text? No. So S, such that S has to be a whole number. And likewise, R also has to be a whole number. So there we go. There's our numbers, our variables restricted. Now we need to find our equations. So let's go back up and let's take a look and find our equations. So he received and sent 60 text messages. So that's a total. That makes it easy to write the number he received plus the number he sent equals 60. That's the first equation. Now let's look for the next equation. He sent 10 more than he received. So the number he sent was 10 more than he received. So how do we write that? He sent 10 more than he received. So the number he received plus 10 is equal to how many he sent. All right, now we've got two equations here. Now we can graph these two equations on our graph. All right, the first thing we need to do is we need to find some points that we're going to work with on here. Okay, so our first equation is in standard form. So our first equation right here is in standard form. So let's get our intercepts because it's in standard form. So here's our equation. R plus S is equal to 60. Our R-intercept, we set S equal to 0. And when S is 0, our R is going to be 60. So our R-intercept is going to be at 60 and 0. Now, I chose R to go first and S to go second. Now, I did that because it doesn't really matter which ones are independent and dependent variable. So I put them in alphabetical order. All right, now our S-intercept. Well, we set R to equal 0. So this is going to be 0 and 60, the same thing. So those are our two intercepts. All right, so let's take a look at the graph, and let's put stuff on the graph. So our R-axis, I shouldn't zoom out, I should zoom in. Our R-axis is going to be here, received messages, and our sent messages here. And we're just going to count by tens, 10, 20, 30, 40, 50. There's 50, 60, 70, 80, 90, 100. Going the other way, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right. So our equation number 1 It goes 60 on the r-axis, 0 right there, up to here. It's a very simple one. Now let's take a look at our second equation. Our second equation right now is almost in like y equals mx plus b form. Y equals mx plus b form. But we want to rearrange it so that it's easier to see. So s is equal to r plus 10. Now it's in y equals mx plus b form, except instead of y we have s, and instead of x we have r. Our slope is 1 and our start point is 10. So we come back here, our start point's at 10 and our slope is 1. Now our slope is 1 means we go up 1 over 1. But in this case, it also can mean going up 10 over 10. So up 10 over 10 like this, like this, like this, like this. Right there is our graph for our second one. Now this one can keep going on forever. Okay, so let's find the point on R and S where these two graphs intersect. And we can see the point of intersections right there. Again, this does not lie directly on a given point in the graph, so we have to interpolate a little bit. So we're looking at where this point is. On my r-axis, how many he received, I've got him receiving 25. On my cent axis, I've got him receiving 35. Now we can verify this equation because this is pretty easy to verify because 25 plus 35 is equal to 60. And it's also easy to verify because 10 plus 25 is equal to 35. So he received 25 text messages and he sent 35. And he sent 35. All right. Now, if we wanted to check this for sure, we could go to Desmos and you could check it to make sure that it is an exact answer. Although, since we already verified it in our equations, we know that it's right. All right, I hope this found this helpful. If you have any questions, please put them in the comments below or contact me directly. Thank you for watching.